All right. If you're a software engineer working with LLMs, you totally know this feeling, right? Building that first proof of concept, that's the fun part. But the real challenge, the thing that separates a cool demo from an actual product, is getting it to production. Today, we're handing you the playbook to finally bridge that gap. This is the question everywhere, from big events like the India AI Summit to literally every engineering stand-up. We see all these mind-blowing demos, but the actual path to a scalable, reliable app that real people can use, it often feels like a total black box. Well, this explainer is your map. And this says it all. On the left, you've got the dream, a few clean lines of LangChain, and boom, it works. But on the right, that's production. It's a whole different animal, wrapped in layers of monitoring, routing, and all sorts of safety nets. This gap right here, this is where good projects go to die. So let's put it this way. You've got that awesome PoC running on your machine. What's it actually going to take to put that in front of millions of users without it crashing and burning, or costing you an absolute fortune? That's the problem we're going to solve right now. Okay, so here's our game plan. We'll kick off with the production problem itself, then jump into the big shift from MLOps to LLMOps. After that, we'll give you a starter kit of tools, show you how to debug your pipeline, scale without going broke, and wrap it all up with your production-ready playbook. All right, first up, the production problem. Let's be real, that jump from a nice, clean Jupyter notebook to a messy, unpredictable live environment, that's where most AI projects completely fall apart. And believe me, when they stumble, it's not pretty. And when things go wrong, they go spectacularly wrong. We saw an insurance firm build this amazing PoC for automating tickets, but in production, it hallucinated like crazy and user trust just evaporated. Costs can spiral from $10,000 to $100,000 a day. Latency spikes kill the user experience, and managing 50 different prompt versions becomes a total nightmare. This is exactly what happens when you don't have a real LLMOps strategy. Okay, so you might be thinking, hang on, don't we already have MLOps for this? Well, you'd think so, but as we're about to see, the entire game has changed. LLMs demand a totally different way of thinking about operations. This table just lays it all out. They're night and day. Traditional MLOps was designed for structured data and predictable things like accuracy. But at LMOps, it's a whole new discipline built for unstructured data, real-time feedback, and bizarre new failure modes, like hallucinations. It's not an upgrade, it's a complete paradigm shift. Let's actually look at the code. With MLOps, you'd log a static number, like your model's accuracy. Done. But with LLOps, you need to be constantly tracing dynamic things like token usage and latency for every single call. And that's exactly what this little Langsmith environment variable turns on. And the data itself is the perfect example. MLOps lives in this neat, orderly world of spreadsheets and numerical features. LLMOps, on the other hand, thrives in the wild, unstructured jungle of text documents, especially when you're doing something like RAG, Retrieval Augmented Generation. Your whole data pipeline has to be rebuilt from the ground up. So how in the world do you wrangle all this new complexity? Well, you need the right tools. Let's build out the essential starter kit that every serious LLM developer needs. First on the list, LangChain. The best way to think about it is like the glue for your entire LLM app. It gives you all the building blocks, the chains, the RAG components, the agents, and lets you snap them together to build really powerful and complex AI workflows from simple parts. Here's what a super simple chain looks like. It just connects a language model to a prompt. Now, it looks simple, but this modular design is the foundation for everything else you're going to build. And hey, quick pro tip. When you go to production, use a low temperature setting. It makes your model's output way more predictable and safe. So you've built your awesome chain with LangChain, but how do you know what's actually happening inside it? It's kind of a black box, right? You can't fix what you can't see. And that's where our second tool, Langsmith, comes in. Honestly, the magic is all in this one line of code. It's almost unbelievable. You just set this one environment variable, and Langsmith automatically starts tracing every single step of your application. Suddenly, you can see everything. Latency, token usage, costs. It is an absolute game changer. Okay, last piece of the starter pit. Remember that RAG pipeline we mentioned? To give your LLM new knowledge, you need a special kind of database to store and search through it, and it has to be fast. That's a vector database, and Pinecone is a fantastic choice. It's serverless, it's managed, so you get all that high-speed search power without any of the infrastructure headaches. All right, time to get our hands dirty. You've got the tools, you're building a RAG pipeline, and then, inevitably, it breaks. It's an incredibly powerful technique, but man, it is full of little traps. I would bet money that almost every developer who's built a RAG app has stared at this exact error message. It's such a simple thing, but when you're in the zone, it just stops you dead in your tracks. So frustrating. And the fix is almost always about one simple thing: order of operations. You have to set your API keys and environment variables first before you import the libraries that need them. It's a tiny detail that makes all the difference. Get your keys in place, then let the tools do their work. Awesome. So your app is working. High five. But now, how do you scale it to millions of users without your API bill rocketing into the stratosphere? Just look at this number, 73%. That's the cost reduction JP Morgan saw by putting in place just one smart LLMOps strategy. We're not talking about saving a few bucks here. This is what makes AI economically viable when you scale. So what was their secret? It's a brilliant strategy called dynamic model routing. They realized they didn't need to send every single query to their most powerful, most expensive model. Instead, they built a smart traffic controller. Simple questions go to a cheap, fast model. Only the really tough ones get routed to the big guns. It's that simple and that effective. Whew. Okay, that was a lot. So let's bring it all home. Let's pull everything we've talked about into a clear, actionable playbook that you can literally take back to your team and start using tomorrow. Here it is, your roadmap. In week 1, your one and only job is visibility. Get Langsmith in there so you can see everything. By month 1, you've got to get a handle on the spending, so you implement cost circuit breakers. By month 3, you're ready for the big leagues, deploying on Kubernetes with model routing to handle real scale. And by month 6, you're establishing a full prompt registry for proper governance. So there you have it. That's the playbook. This is the proven foundation for moving past the hype. The gap between a demo and a production-ready AI application isn't magic. It's just good engineering. You have the guide. So the only question left is, which part are you going to implement first?